thanks for checking out Chemistry Connections on the Hopewell Valley Student Podcasting Network, a proud partner of hvspn.com, where students come together to publish content to share with the world. The opinions represented within this episode are those of the content creators only. Please enjoy the show.
Welcome to Chemistry Connections. My name is Maxxe Rice, and I'm your host for episode number 2, called The Chemistry of Chipotle. Today, I'm discussing the best food known to man, Chipotle. For this first segment, I will be discussing an introduction to what Chipotle really is. For those who don't know, Chipotle is the best fast food restaurant ever that serves Mexican-inspired cuisine. They are infamous for their delicious burritos, bowls, quesadillas, chips, and guacamole, and really you name it. The restaurant is set up so when you're ordering, you order in like an assembly line style in which you customize your burrito, bowl, or really whatever you're choosing to get. And as you go down the line, there's workers at each part of the line scooping the ingredients for you. They go by their motto at Chipotle that real is better. Better for you, better for people, better for our planet. They make their food fresh every day because of their motto. And they use no artificial flavors, colors, preservatives, no freezers, can openers, or shortcuts. I know, I really wouldn't want to work there either. It seems like a lot of work. But really, that's what makes them so good. They are committed to their amazing food, and they only use 53 real ingredients. There's also an extreme debate about how to pronounce Chipotle, especially with my grandparents and I. My one grandma calls it Chi-poat-lee. My other grandma calls it Chih-poat-lay, but all of those are wrong. The correct way to say Chipotle is Chipotle. Now that you know what Chipotle is, let's dive into some of the science behind this outstanding food. Specifically, let's start with a common ingredient in Chipotle's renowned guacamole, red chili salsa, fresh tomato salsa, roasted chili corn salsa, honey vinaigrette, tomato green chili salsa, and really so many other foods that if I sat here and said them all, I would be talking for almost 5 minutes. One ingredient that all these foods really have in common is some type of pepper. Weird. Why am I talking about some type of pepper? What does that mean? Well, these peppers all have something in common. Spice. This is where the chemistry comes in. Because, well, the spicy flavor that you taste with some of Chipotle's food is due to a spice molecule named capsaicin. I know what you may be thinking. What? Yes, you heard it right. Capsaicin. Capsaicin is my cool friend that basically has active chemical superpowers. Capsaicin has the molecular formula of C18H27NO3. It is an organic molecule which is made of a benzene ring with a long hydrophobic carbon tail and a polar amide group. Whoa. Let's take a further look into the actual structure of the molecule because that sounds really confusing. A benzene ring is a ring formation of 6 carbon atoms that are bonded together and have alternating single and double bonds between them. The long hydrophobic carbon tail means essentially a chain of carbon atoms is bonded together with surrounding hydrogen atoms around them bonded to each carbon on the chain. The polar amide group is part of the molecule where there's a nitrogen atom and a double bonded oxygen atom. We can break this molecule up into 2 different polar regions and 1 nonpolar region. Now, what makes something polar? Well, something is polar if there's asymmetry in the molecule and if there is a difference in electronegativity between the atoms within the molecule. Electronegativity is a tendency of an atom to attract shared electrons when forming a chemical bond. With larger molecules, We don't tend to just get one solidly polar or nonpolar molecule, but a molecule with different regions of polarity because they're so big. The hydrocarbon tail contains a difference in electronegativity because of the difference in electronegativity between the hydrogen and carbon molecules. However, it's still not polar due to the symmetry of carbon and hydrogen atoms that make up these chains. Therefore, this part of the molecule is nonpolar. On the other hand, the part of the molecule that contains the amide group and benzene ring with the OH attached to it is an example of a polar section of the molecule. This is a polar section because of the asymmetry of the different atoms and difference in electronegativity between the different atoms as well. Okay, now more about what it actually does in the pepper. Capsaicin is an organic molecule that is contained within the membrane of peppers. This membrane that capsaicin is in holds the seeds in chili peppers, or really all peppers, which, fun fact, contrary to what most people think, and what I found really interesting, I always thought that it was the seeds that were the specifically spicy part of the peppers, but that's not actually the case. See, when you eat something with capsaicin, you feel the burning sensation of something being spicy. This happens because the molecules have a unique shape and size, which allows it to react with the TRPV1 receptor, which is a special receptor on your tongue that creates a chemical response in your body. Specifically, the calcium ions go to that receptor and trigger neurons to be released. Neurons are cells that essentially talk and communicate with your brain and tell them that there is a burning and spicy sensation in your mouth when you eat foods containing capsaicin. In addition to there being chemistry behind the spice in Chipotle's foods, there's also chemistry behind how Chipotle keeps their incredible food so warm. In order to ensure that the food is getting to our plates the freshest that it can, Chipotle uses a water bath-like heating system in order to keep all the food warm at all times. The food is held in separate metal containers, each ingredient in a different metal container. These containers are then slid into a big metal bin-like structure that's in the counter, which has some water filled at the bottom of the bin, but not enough to physically touch the separate metal containers that are slid into the top of the bin that contain the food. Underneath the big metal bin that's installed into the counter, there are these burners. Let's follow the heat transfer from the burners underneath the bins all the way up to the best food ever. First, the burners underneath the bin are fueled by propane. Propane is a burning fuel that's used for light and heat. It's stored under pressure inside a tank, and it has an odorless, colorless liquid inside of that tank. When the burner is turned on, pressure is released from the propane tank, and the liquid of propane vaporizes, turning it to a gas that is used in the combustion reaction in order to create heat and light. Let's take a step back. A combustion reaction is a reaction in which a substance reacts with oxygen gas and releases energy in the form of light and heat. Specifically, the reaction that propane undergoes is written as C3H8 plus 5O2 reacts to form 3CO2 plus 4H2O plus heat. This reaction means that propane and oxygen react together in order to create carbon dioxide, water, and heat as products. This combustion reaction of propane is an exothermic reaction. An exothermic reaction means that the reaction releases heat and light in the form of creating a flame. This reaction being an exothermic reaction also means that there is more energy released when product bonds are formed and less energy is absorbed when reactant bonds are broken. Heat from the exothermic combustion reaction is then released to the stainless steel metal bin on top of the burners. Chipotle uses stainless steel metal for the material of their containers. This is because metals are amazing conductors of heat. Stainless steel specifically is made up of the metals iron and chromium. Iron and chromium atoms form metallic bonds between their atoms. Metallic bonding refers to the chemical bonding that takes place between metal atoms in which electrons in the outermost energy level of an atom are shared by all the atoms in the metal that's created. This bond creates what they call a sea of electrons. I know, kind of a funny name. Now, we call this metal such a great conductor, but what is a conductor and what makes something conductive? In order for something to be conductive, the substance must have charged particles that are able to flow. Now, in iron, because of the sea of electrons, due to its metallic bonds, iron has free-flowing electrons. Electrons are charged particles, so that's one check off the list, that can flow in the sea of electrons. Flow, another check off the list. Therefore, iron is a great conductor and is great for transferring energy, just what Chipotle needs. Iron conducts heat from the burners underneath to the water that is present in the bin. When the water bath gets heated, the water molecules move faster and faster and gain more energy, eventually leading to the intermolecular forces, which are hydrogen bonds between the water molecules, to break, which then the water molecules change phase from liquid to a vapor. Water vapor molecules move very fast and have a lot of energy, in which the water molecules then collide with the smaller stainless steel containers, which are slid into the top of the big metal bin. The collisions from the water vapor particles with the small metal bins creates another energy transfer, and the metal bins are heated. The stainless steel is then able to heat up and conduct the heat energy to the food that the bins contain, resulting in the food staying warm. Now, you may be thinking, well, why Chipotle? Kind of random. Well, the truth is, I chose Chipotle for my project because it is my favorite thing on the face of the earth. I'm so serious. I first tried Chipotle in the first grade. I remember the exact day. I got a bowl, and I just have been hooked ever since. As soon as I took my first bite into my food, I feel an insane feeling of serenity and euphoria. The food is just so good, and it makes me so happy. I just love it, man. And it's important because other people will love it too if they tried it. It is also a plus that I happen to love chemistry, I happen to be in AP Chem, and there's just so much chemistry involved in Chipotle, as I explained during this podcast, which just makes it another plus. My order, if you would like to know, is a bowl with a quesadilla on the side. That's the real life hack, so you can make a burrito with some of your bowl while you were eating. Then I get white rice, chicken, pico, corn, lettuce, cheese, sour cream, guac, and chips on the side. Alright, now I'm done talking about Chipotle, but it really is the best food ever with the best chemistry. Thank you for listening to this episode of Chemistry Connections. For more student-ran podcasts and digital content, make sure that you visit www.hvspn.com.